Okay, so we should be recording now.
Thank you.
Sure. Now, the so that's the load flow, and it just as in version 5, you run load flow. It's going to run on your model, and your model is a peak model, so that means that it's some representation of loads, probably the largest loads or each load at the peak, um, and the model has been allocated and all of that. So it's a load flow that's the same kind of load flow that's been run for 30 years. Now we are putting a lot more focus onto all these different load flow tools here to the point where we're in the next update of Synergi, we're assuming that everybody is running time-based models, in that the model is going to be different hours of the day. And to see the results of that, I'm going to, instead of running load flow, I'm going to run this analysis that has a 24 under it. And so that is going to look at our model in August, on a weekday in August, and run through a 24-hour period. And so it runs here, and I can see the demand on my system. I have 2 substations selected, and we can look at this chapter or this report right here. Another thing that's a lot more prevalent in version 6 is that we utilize charts much more. So many of the applications, they only generate charts, and because the information is so vast and there's so many details, we're trying to present it in a way that you can look at the chart and kind of make sense of what's going on. So this chart right here is the green line is the actual demand on these 2 substations, and this red line right here, this is the PV generation. And we also have a battery down here. It's a 1 megawatt battery that's operating. And so would be the renewables, or the distributed energy resources on the system. And then what we can see is that this is the actual demand, and this blue line would be the demand if we did not have the renewables operating. So I was Googling some last night, and from what I can tell, the growth of photovoltaics in Mexico is one of the highest rates in the world. And it seems like maybe the last 2 or 3 years, solar power has really exploded in Mexico. And let me see, I'm going to switch to a slide deck here real quick. This might be a good way to look at we've put a lot of effort, along with our clients, into modeling generation, solar generation, wind power, and battery storage. And so the result is, analysis like I was showing you, where you can see the impact that the renewables have on your system. Now, we are modeling solar in 3 different situations, and you all can tell me where you have the most concerns and the most growth perhaps in solar power. But we're modeling solar farms like this, and that would look like a standard or a standalone generator on your system, and it would be a solar powered generator. This is a rooftop, a commercial rooftop. And so warehouses and shopping centers might have solar arrays on top. And then here, this is the residential rooftop. So in the West Coast of the United States, our clients are usually more focused on these, the residential rooftop, because there's a substation. Some substations I've seen will have 1,000 rooftop generators on them. And then as we go from the West Coast to the East Coast in the United States, then the focus is more on these large generators, especially in the Midwest, where they'll have, there's more room. They'll put in multi-megawatt solar farms, and then they connect them to the distribution system. So for you all, what is a situation in your system for solar power?
Okay. In Mexico, the connection and the middle voltage, 30.5 kV low. The small generation is growing through rooftop. Yes, and large generation like you are showing in slide is not connected at the distribution system. It is connected through substations or in high level voltage.
Okay. So it's residential rooftop, and do you have a lot of it? Is it something that you study and you have concerns about?
There are maybe the in the figure the industrial generation, the warehouse is also of concern for us in distribution.
Okay. Okay, good. Just taking notes here. Okay, yeah, that's good to know. All right, so maybe I'll come back to some of these slides here, but so we can run a analysis over time, and one of the big drivers for that is to be able to look at distributed energy resources and how things are changing throughout the day, because the system is much more dynamic now, and problems may not necessarily occur at peak load. In fact, you know, the minimum daytime load is where a lot of utilities are studying because people, if I look at the load chart here, the loads drop down in the middle of the day. The system loading goes down for loads, but then the PV generation will pick up. And so that is a situation with overgeneration. And so some utilities don't want reverse power flow. There's concerns about high voltage and, you know, so on with solar. So modeling over time is important for that. So we have the 24-hour analysis, and then the next step is the 576 analysis. And I'll run it, and then what Synergi is doing is it starts in January, and it's running all the way through December. And when it finishes, we've got a charts here that show the demand on the system for each month. So across the bottom is the legend, and we can see that the demand on our system, this olive colored is in the summertime, and then this high demand is in the wintertime. So we have a winter peaking system here. So we can see the demand, and we can also look for things like voltage problems. So here is the maximum voltage levels, and it's fairly chaotic because we have automated devices, voltage regulators, transformer load tap changers, switch capacitors, things that are operating that gives us this, you know, a lot of, it looks like a mess. And so we can come in and put boundaries around the chart so we can see the maximum voltage and the minimum voltage on these two substations throughout the year. So now you know, we can see we've got some voltage problems out here. It's usually happening around 1700 hours. It'd be about 5 o'clock in the evening. So we've got problems, and we could go back and see what months do we have these problems? What's December? So then we could go back and just look at December and run load flows just for the month of December and try to identify what the problem is, when it occurs, and so on. So we'll talk about these applications more, but I want to switch over to your model. And but before I do that, a couple things I want to show you. Um, I'm not able to get them to work with your model. What I'm going to do here is going to come in and let's look at a 576 analysis. This is a showing where we have the most voltage variation throughout the year. So this is and this is new in version 6 as well. The results we have on a tab. So if you want to color the map, it's very easy. You just find the results that you want, like I did, and you just click on it, and then the map is colored with those results. And we have a legend bar that floats around here with a pie chart, and it says that my red is around 5 volts. So this feeder right here, throughout the year, I could see maybe a 5-volt variation in voltages, and maybe that's not a problem, but it's a way to see where you have susceptibility to voltage variation in your system. So if I did have a customer complaining about voltage flicker, those sorts of problems, then maybe that customer is out in this area, or I might be paying extra attention to customers with voltage flicker issues in this area, just because it's more sensitive to voltage change. Anyway, so I've colored the map here, and we can right click on this and open this in Google Earth. And Google Earth is I think is a freely downloadable product, and we found this very nice. Now the reason I tried to use this with your model, but I don't have the projection file. The projection is a text file that has all sorts of information about how your maps are laid out. And so I tried to find some. I experimented a little bit, and I just could not find one to fit your data. So later on, you all might have a projection file, and you could send it to me, and I'd be happy to try it on your model. But Google Earth is very nice, and I'm sure it would look just as nice for your system, and for the land base down in your area. And you can see here's a substation. So here's a substation, the switch gear, my line's taking off. Utilities that have solar power, it's really great because you can see the lines coming in, you can see the rooftop solar. So using Google Earth is a great feature, and you can get to it just by right clicking on the result. We also have a geographic view inside of Synergi. So on the Views tab, this thing called the Geographic View is here. And if I bring it up, this is a more interactive display. It's a street map view. Let's see if it comes in here. And it's tied to the to data that we provide on the internet. So it has to go out and grab the land base and bring it in. But it's similar, and you can see the roads, the lines, and all of this, and it will synchronize to your Synergi map. So as you pan and zoom around, this will synchronize to that, so that you can associate areas on your Synergi map to a real-world map like this. Our goal is to have this sort of display as the one and only map in Synergi. We're not there yet, we've got work to do to get there, but that's our goal. But for now, it is nice to be able to have a map display that you can easily get to. Okay, so for those two things to work, you have to have this projection file, and um, it's a PRJ file. It's usually something that the GIS uses, and so if you have that, or if you can tell me what it is, then I can load it and see how your models line up with it. In the preferences of Synergi on the map tab, there is a link that takes you out to a place where you can look up different projection files. So I was out here this morning, and these are some of them that they have. And so there's a bunch in here for Mexico, but these are just files that folks have posted to this site. The PRJ files, you might have a customized one. And so if it's custom, then you would need to use that for these things to work. So anyway, that's the bottleneck there. So I'm going to go in and grab this this model, and I'm not going to try to pronounce it because I'll mess it up. I grew up in New Mexico, and so I know enough Spanish to know I'm not going to pronounce that right. So, but this might be a system that you recognize here, part of your system. One of the biggest areas that our clients are working in and talking about is this concept called hosting capacity. And so the question is, how much solar generation can we put on our system so that there's not a problem? And so in Synergi, this is your model from 2012. And you come in here to this tab, this DER, Distributed Energy Resources tab, and this is another one of the big advancements in version 6, is we've got a tab dedicated to this. We have all sorts of applications around DER. But the one that folks are interested in is this incremental hosting capacity. And we have different types of hosting capacity analysis over here. But the incremental one is the one that generates heat maps. And so if I run it, I'll turn off my reports and I'll run incremental hosting. And once it finishes, then I go to my results tab here and my PV incremental hosting, and I can click on the maximum generation. I imagine it's hard to see the text here, but this is the generation maximum megawatts. And then if I show this legend, then what we've got are that the red areas are around 8.5 to 10 megawatts. And then it goes down from there. So the blue lines are anywhere from 500 kilowatts to 2 megawatts on these lines. And we could double click on the sections, look at the results, and see the specific values for these sections. So if I wanted to know, what's the hosting capacity on this particular section right here, I could just bring up the section editor, look at the results, and it's 1.5 megawatts. That seems like a lot. Now, what are we looking at for hosting capacity? Well, we're looking at 5 things. We want to make sure that the generation is not going to cause a overvoltage, or an under voltage. So we want to make sure the voltage won't be too high or too low. the other thing is delta voltage. So if that generator were to trip, will it cause a change in voltage that exceeds our limit? The fourth is thermal overloading. So we do not want to overload any line section or piece of equipment from the point of connection all the way out of the feeder. And then the last one is reverse power flow limits, and those are arbitrary limits that utilities will specify. Some utilities have a reverse power flow limit of infinity. They have none at all. And others will have theirs set to to zero. They will not allow any reverse power flow. So you can specify what that is. So we look at those 5 things and then use that to generate the heat map for the distribution system. Now, I know that you all have work going on with EPRI and the drive application of theirs, and that's completely fine. We feel like distribution engineering is that's the area that utilities, that's the reason utilities buy our software, is the tools that their distribution engineers need for analysis. Hosting capacity is a primary issue today for all utilities, and distribution engineers throughout the world are trying to deal with hosting capacity. And so it's critical that that we provide the tools to do that hosting capacity analysis. There are utilities that automate our hosting capacity, put the results into a database, and then use that database to publish maps on the web. Our hosting capacity deals with all of the modeling complexities. It's a biphase analysis. It deals with switch capacitors, tap changers, transformers. It analyzes as many feeders as you want. You can load in multiple substations and analyze all the feeders. So it doesn't just do one feeder at a time. And we're progressing with this. We've got a lot of features in hosting capacity, and we're continuing to move forward to deal with things like switching, switching is the next big step, where the hosting capacity really should depend on switching alternatives that you commonly activate in the field. And so that's going to be an interaction between hosting capacity and things like contingency analysis. So a lot of work with hosting capacity, and it continues. You may have noticed that we have load down here as well, so we can look at the maximum load on the system. And the reason for that is that, and this, I noticed this feeder down here already has an overload on it. So it has a pre-existing condition. It's already like 106% loaded. And so the loading capacity is 0 for all of this. The reason we have the load in there is for car charging, energy storage, battery systems, things like that. And so utilities will run the hosting capacity and the load capacity analysis at the same time. Some other applications in here. We have another, let me turn on the reports and we'll do the incremental again here with the reports turned on. And it runs, I've got a rundown of all the feeders and the maximum and the minimum. So which sections have the highest hosting capacity and which sections have the lowest. And you'll also notice that this is time of day dependent. Right now, I have Synergi set to run at 8 o'clock in the evening on a weekday. But we can have hosting capacity run over the full day and the entire year. And when that happens, what we'll see is that we have the limits occur at different times of the year, different times of day, different times of the year. So if you want the overall limiting hour of the year, you can run it that way. And you might say that, well, the hosting capacity on this section was determined at during June, and the the limit for another section might have been determined in August. So that's very important for a lot of utilities because they want to capture the dynamics of how the system is changing throughout the year and how the hosting capacity may change as well. The GROW method is it's another form of hosting capacity, but it does not produce a heat map. What it does is it simulates the addition of solar power um, throughout the system, and it just continues adding solar generation until there's a problem. The incremental approach with the heat map is looking at how much generation can I add to this section and that section and so on. The GROW method is adding PV uniformly or all around the system. So the GROW method is more appealing to utilities that have a lot of residential rooftop, because with residential rooftop, you've got small generation units and they're all over the place. And so a more uniform approach makes sense. And the GROW method gives you a feeder number. So instead of having a heat map like this, you would have a list of hosting capacity values for each feeder in your system. So all these feeders right here, the GROW method will produce a report, and I'll just run it here. It's going to be quite a bit, it looks like. So there we go. So then how much PV can we add? And so some of these are zero. I have to look and see why. It's probably some sort of a data issue. But these feeders in here, you can see we have a, zoom this in a little bit, 17 megawatts. We have big numbers for these feeders. And maybe you expect that. And the limiting factors are listed over here. So we've got fuses, which I would go in and disable that, because I don't think it makes a lot of sense to have hosting capacity limited by fuses when they can be changed so easily. But you can see how this application works. It gives you megawatts for each feeder. Then you can have a system that is adding up the connected PV, and if that total exceeds this, then, well, you've exceeded the hosting capacity. The stochastic one is kind of a combination of the two. You put in probability distributions. So these are small solar generators, residential sizes, so 6 kilowatts, and so on. Over here, these are large solar farm sizes, and the stochastic analysis will randomly, it goes through and just randomly, using these probability distributions, randomly determines sizes and locations, adds solar power until there's a problem, and then repeats the process. And when it's all finished, you have a cloud. Let me see if I can grab one of these. I could probably do it on this. I'll run it on here, and you get a cloud that shows what, if we're looking for maximum voltage, we've got, I think we must have a tap changer or a regulator in there, and then it picks up. So it's I ran this, I think there was maybe 8 profiles. You'd want to run it with 100 profiles. And so you get a cloud here. And then you can look at this cloud and figure out what your hosting capacity limit is by the intersection of your your voltage limit against this cloud. And so it's a good approach. Several national labs in the U.S., maybe folks in Mexico, um, promoted this approach years ago, and I think it's still a great approach. So we have this in Synergi. So hosting capacity is you know is important for all utilities, and so we have a lot of capabilities in here for that. Now, since I've got this feeder of yours, let's see, I'm going to select these 2 feeders here. And earlier I was running the 24-hour analysis, and if I run this on your system right now, on these 2 feeders, this is over a 24-hour period in August, and I've got the demand is a flat line, and I have no PV generation. And I want to show you how you can start to represent the time varying aspects of your system in Synergi. So what I'm going to do is grab this tool in Model Forge. This Forge tab is, I think it was in version 5, but we have put a lot of work into this as well. The Model Forge is a system that you take SQL for a database. You take SQL language, you write out SQL statements. Synergi runs that SQL against a database, takes the query, the results from that query, and then uses that to build the model or to update the model. So we've got lots of utilities using this. And Model Forge, we started thinking about this when we did the model build work for you all back in 2009, because we were building the model directly from a database, writing SQL. That SQL is for CFE is actually productized. It's actually compiled into Synergi, and that's not good. Model Forge is open, and so if sorry, I don't want to look at the schema here. I'll show you. I'll show you what one of these scripts looks like. It looks very complicated if you're not an SQL person, but all this is just SQL. It's database language to get data out of the database. And so a utility that has Model Forge, they can come in, oftentimes our consultants will build the SQL. They'll work with the utility, they'll build the SQL, but after that, anyone in IT or engineers can come in and modify these. If you want to get data in a different way or you want to get more data, you can come in and work on this. So it's completely open. It's not compiled in Synergi. So this is all the SQL, and then further down is just the mapping, where we take the SQL and we map it to Synergi. And that's all this stuff does. So it's very simple. Write the SQL, then map the SQL to the model. So between version 5 and 6, this thing has exploded. Many utilities use it, and we've done a lot of great work. We continue to just about every day. We're putting in more stuff in Model Forge. Now, Data Lake is a new addition to Synergi, and it has evolved over several updates, and it works really in conjunction with Model Forge. The data lake concept is that if you have a bunch of data that's just sitting out, and maybe that data is used by other systems, maybe you have data for displays or for load management systems or customer systems, things like that. Well, how about if Synergi can go and just grab that data and bring it into the product? So that's the vision for Data Lake. I think we still have work to do, but that's the idea. And Data Lake is a very common term. The folks in the IT, I'm sure, know the term well. And a data lake is just a bunch of data that's kind of loosely related. A database is very tightly related data. A data lake is loosely related. So anyway, I'm going to go and run Data Lake and grab data for this feeder, or these two feeders. So the Data Lake, you can pull data in from spreadsheets or database or text files. So I'm going to grab data from a spreadsheet. I've got a bunch in here. Now this is actual client data, but I changed the name to match these two feeders. And I'm going to find them here. Here, the Philo 4145 and 4155, these two right here. I'll show you what the spreadsheet looks like in a minute, but the spreadsheet has a lot of tabs in it, and these are all the tabs in the spreadsheet. The data that I'm going to load is 15-minute interval demand data for two feeders. So it's every 15 minutes for a full year. So that's 8,760 hours and 15 minutes. So the spreadsheets have, or these tabs have 35,000 rows, each of these do. So that's what the MTR 106 code means, is it's a spreadsheet with meter demands. And it can be 15 minutes, 5 minutes, every 3 hours, anything you want. There's other sorts of spreadsheets in here. You can see I've got some demand data. There's generators. If you have a list of generators, you can put those into a spreadsheet, and then we can load that spreadsheet in. There's irradiance data for solar energy. So I'll click on next. It takes a little bit. It's looking through the spreadsheet, making sure it can understand. And then it says, okay, we can import the data, and I'll go to finish here. So it's pulled in those 70,000 data points. And now if we go and run the 24-hour analysis again, now instead of it being a flat line, because remember before it was a flat line, this was before when I ran load flow, it was flat. And now I run it and I've got this variation. So this is a engineering generalization about the loads. Some utilities will go in and develop customer class curves. So they will go in and do customer load research and develop curves like this one for electric customer class. And then they'll take those customers, figure out how many customers are on each section in the model, and develop the connections. And once all that's done, then they can run the 24-hour analysis. And the loads are all changing by hour because of that load research. But you could imagine that's a lot of work. You've got to collect a lot of data, do a lot of data processing. It's complicated, tedious work. You all, utility your size, you might have economists and statisticians who do that kind of thing. I see that at big utilities a lot. And so you might have those capabilities. Even if you do, it's still a lot of work to get that information from those groups into the engineering model. So what we did was put this data lake tool in there so that you could import feeder demands. So each of these feeders has a meter sitting right here, and this is where you would put in demands for load allocation. In version 6, we have these profiles sitting here. So I opened up the meter, and then I'm looking at the profiles. And when I did that import from the data lake, it brought the data into this profile right here. And this utility is a very arid, it's a desert region, and they're winter peaking. So you can see the summer, the air, so you get more shape because of air conditioning. I said winter, they're summer peaking, and then it drops down again. So it's very good. I mean, this is the actual demand on the meters. That's great. We're using it to represent the load behavior of all the loads on the model. Now that's an engineering estimation because there's probably no single load in this feeder that is doing this exact thing. But all of the loads together are doing something very much like this. So it's a good engineering approximation. The great thing is that the data is available, and you saw how easy it is to bring the data into Synergi. So now we're able to model the PV, or I'm sorry, the loads, and that's very important. There's three things that are very important to doing DER studies, connection studies, those sorts of things. One is some sort of time-varying load model. The second one is the solar generation model. And then the third one is a substation. And I noticed you don't have substations on these feeders. And we could talk about that later, but there's different ways to get a substation built into these. What I want to do now is put a solar generator in here. So this will be let's just say this is a commercial rooftop. So we go into the warehouse under the generators, and I'm going to do is just copy one of these. So I'll do a copy as, and call it solar rooftop. This is work that we're working on a lot, and it's gotten simpler, and I think that is an indication of how much work we've put into it, because we want it to be simple and very straightforward, and for you to be able to model PV and be confident that you know what's going on and that things are working well. So when I create a warehouse type for the solar rooftop, I want to mark it as photovoltaic. That's very important. Do not use the constant PQ at all. We probably should just take it out, but you want to use photovoltaic. And here we want this to be a larger unit and three-phase. And that's really all you have to put in here. There's other settings. We're probably going to have these grayed out in the next update so that you don't have to worry about these at all. So it's very simple. I just need a warehouse type that's marked as photovoltaic. Now I can take this solar rooftop and drag it and just drop it onto the model. So I'm just going to drag it and drop it right here. And when I do, I get a little generator symbol, a solar generator symbol, a little sun. And when I open up the editor, now I can come in here and set this thing up. Let's make it 500 kW. And I could set the inverter up here, 100. And there's a lot of stuff that we can get into. We do have, well, let me finish with this and I'll show you the inverters. But so we got 500 kW. And now for this, so anytime I want to have a solar generator, I can just drag and drop this solar rooftop onto the model. The irradiance, this is a one-time thing that you would need to do. So for your warehouse, somebody needs to go in to the global irradiance, put in your latitude. I looked up Mexico City. It was 18 degrees, so I put that in for the latitude. And then you press this button, and Synergi calculates what the irradiance looks like for Mexico City, or for the latitude and longitude. And so this is what the curve looks like. And so you just have to do that one time. Now, when we go in and we run the 24-hour analysis, now we have PV generation, and we have the loads, and so we can see this impact. So we can see that the green curve is your demand, and the blue, so we can see the shift due to the PV generation there. So this is your model from 2012, and with just those two things, I'm able to get this thing set up to do a 24-hour analysis. It should even work on a 576 where we can look at the entire year. So here's our, and again, I mean, these demand profiles are not from CFE. They're from another utility. So, I don't know if this is even close to realistic or not, but so we can see the demand, we can see the generation, and now we have this time varying model. There's a lot of other things. The 8760 will allow you to run the model over every hour of the year. The 576, I should have explained this before. 576 comes from 12 months. So you take 12 months, and there's 24 hours in each day, and we have weekends and weekdays. So 12 months, 24 hours, 2 day types. If you multiply those numbers together, you get the 576. A lot of folks talk about 8760, and that would be 365 days times 24 hours a day gives you 8760. But the difference between these two is that in Synergi, we treat every weekday the same for a given month. So a Monday, Tuesday, Wednesday in August is going to be the same. If you're running an 8760, they're going to be different. So August 27th is going to be different from August 28th. You've got to have some way to tell Synergi what those differences are, because all of the data in Synergi is based on those curves, the 576 curves. So with the 8760, and I won't run these, but you can go in and point to a database that would have your distribution transformer demands for every hour of the year. And that it's going to be a huge database. There'll be gigabytes of data there, but we can go in and run a full year analysis with that data. You can also put data into spreadsheets. So those are a couple of options. So that's an hour by hour of the entire year. That's important for some utilities. I think that 576 is a much stronger approach because, no matter what we want to believe, there's engineering judgment behind all the data. All this data is collected, it's run through systems, it's got errors in it. And so just because we're running 9,000 load flows doesn't really mean the results are any better. So the 576, I feel like the data is more compartmentalized. We know exactly what the data is, what it means, what the shortcomings are. And so engineering wise, I think 576 is better. But 8760, if your utility commissions, your customer advocates, developers, everyone who's kind of outside the power distribution engineering world talks about 8760. It's very popular, and conceptually it makes a lot of sense. Why not simulate CFE's system for every hour of the year to see if there's a problem? So that's why we've got it in there. And it does make a lot of sense if you're doing a point of connection study between a large generator and your system. You want to track down, you want to have a much more detailed study. So the next one here is time series analysis. And let me make sure I got my settings right here. Yeah. This thing runs over a day at 1 minute intervals. So it's kind of the other extreme. So we want to see what's going on with our customers throughout the day on this particular set of feeders. And so with that small generator, we can see that we've got some demands, some intermittency going on. So with the time series analysis, we are incorporating generation intermittency. So the generators are doing this now. And we can use that to look at voltage. So I think there's a switch cap on here. You can see the tap changing on, I'm sorry, let me see, I'm curious now. So it must be the, yeah, it must be the capacitors in there. So I can see something changing taps here, and then you can see the voltage fluctuations. So that's what the time series analysis does. It runs off of a spreadsheet. And so if you have data that you've collected with the irradiance data in it, you can put that in a spreadsheet and use it to drive this analysis. Customers are a big deal for many of our clients today, and I think it's going to be a big deal for all of our clients in the coming years because of the different things that customers can do. Yes.
Sorry. We have some trouble with the sound in Cuernavaca.
Oh, okay. Let me see if it's me. Is that better? Does that sound a little better?
Good.
Yeah. Okay. Yeah. Sorry. With the customers, if we want a utility like CFE to be able to model individual customers, if you all want to do that. Now, trying to put in the transformers, the secondary service lines and all that would be a massive undertaking. And it would be just a huge amount of data. It would make it very hard to sift through it all and to even see what's going on. So what we've done is we've gone into the sections here and we've added distribution transformers. And this would be, so I know that you all have distribution transformers in your data schema. And so they're not getting put into this list. When we do model builds for utilities, when the models come out, they have the distribution transformers listed in here. But I'll add one manually. So I've got a transformer. The size is here. So there'd be a choices and then the connect. So this would be built automatically during the model build process. And then the customers sit in here and we can add a customer in, and the customer has load information and it also has generation information here. So we can have a rooftop, maybe they've got a 6 kilowatt rooftop unit, and we can put in a volt bar controller, and they might have maybe it's a net energy metering program. And so there's this information that you could set up. You can even put in things like thermostat controls and customer demand programs. You can set these up. There's a lot of things that we're doing with customers. The reason that we want to model customers is that if you have issues, the customers are going to be affected and they're going to be the ones who are going to be complaining. And so if there's a high voltage or a low voltage on a customer, that could be a secondary issue. It may be that their neighbor has a lot of solar generation and it's impacting another customer who's you know, on that same distribution transformer. We want to do more accurate loss analysis. So now, if with customers in place, you will see the losses on your model become much, much greater, because without customer modeling, all of the losses are going to be primary. So they're all going to be these the losses through the this is a 14 kV through these 14 kV lines. So it's going to be very small. And you know, if we look at load flow here, I bet the losses are tiny. Yeah. So this one's 2%. That's pretty big. But the numbers I usually see are 1% or less. And that's because all of the loads are modeled as primary. They're sitting here as just distributed loads. And those loads represent the customers and the transformers. So when we're able to now model customers, we can calculate the losses through the transformers. And when you run load flow now, you'll see the loss will become 6, 7, 8%, much bigger. And so it's much more realistic. And if you are looking to justify a capacitor, let's say, to improve losses, now you're going to have numbers that are reflective of the impact that that capacitor is going to have. So the loss information is much more significant, or much more, it's something that you can really use. And then the third reason we're putting in customers is that customers have rooftop solar, and the rooftop solar is going to be connected at their house, at their premise. And if they have something like an inverter on here, there's not one in here, I'll create one. So maybe CFE, you have a typical inverter that these customers have, and they might have a volt bar curve off of the IEEE 1547 standard. You know, there's, and you all might have your own guidelines, or you're working on them for what these points should be. For this thing to operate correctly, we need to have the voltage at the PV generator. And so if it's a rooftop generator, now we can calculate that voltage, because we're going to be determining the voltage drop through the transformer to get to the house. So that's the third reason why we're doing the customer modeling. It's a big deal. You all have 25 million customers, I think, and so that's a lot of data. What some clients are doing is we're putting in an aggregate customer. So they will take on a transformer, they'll take all the customers that do not have PV and create one aggregate customer. And then they'll model customers that have PV individually. And so that seems to be a good approach, just to cut down on the data. So I'm going to run through some other things here. We don't have a lot of time left, but load allocation, we've done a lot of work in version 6 in load allocation, particularly in this area, which is, it's ways that we can allocate loads if you don't know the status of your switch capacitors. So many utilities don't know if capacitors have blown fuses, if they're open or closed or whatever. And so we've got some features here to do a better job of allocating the VARs on customers if you don't know your capacitors. And then we can also allocate all the way down to the customers. That's what this stuff is. There is a system in Synergi Electric 6 called EA Automation, and that's on the Macros tab. And I'll run you through how this works. You start up a wizard like this, and you point to a database. This is the one that I've loaded here, this model. And then you step through the wizard. There's a bunch of options that are just options here. But I finally get to this point where I can choose the analysis that I want to run. So if I want to run, let's say, load flow and fault analysis on that entire database, and I want to put my results into a results database here. Then I set this up. It's probably hard to see. It's even small on my screen here, but so I'm running load flow, fault analysis. I haven't run fault on here. Just going to run load flow. I don't know if the source impedances are set, but you can run 8760, 576. You can also run hosting capacity and so on. And then this is a one-time thing. And could finish this. And then, so going through the wizard is one time. And then from now on, if you want to run this, you just select it and then click on the run. And it's going to load the model from that database. Now, the database that I'm using here is very small. It could be your entire division in a single database. And then this would run. And if you're running like a 576, it might take a while. And that's the reason we built this, is the applications may take a long time to run. And when they finish, the results go into a database. And I'm using Access, but it could be SQL Server, it could be Informix. And these tables right here are so here's my load flow exceptions. So this is a list of all of the exceptions in that database, and the lines, all the voltages, everything. And it's lots of records. And then there's detailed information over here. So the database is not necessarily made for engineers to go in and look at. It's really made to drive reports and dashboards and things like that. So it's designed to be a part of a process. So what some utilities do is, you can see one here, I've got incremental hosting. So this utility, this is actually our sample model here. We have hosting capacity results for every section in this database. And you can also have it run over an entire year so that you can have hosting capacity numbers for every hour and every day type. So this would be for the utilities that publish the maps, the heat maps, those sorts of things. This would generate the data to drive those maps. So that's EA automation, very popular part of Synergi. It's growing. We're adding a lot more capabilities to it. We've done, I don't know if you all do protection work, but version 6, we pretty much overhauled the TCCs and the protection side of Synergi. So it's much more interactive. You can, so this is an ANSI curve here. You can see I can drag it around to the different sizes. That it's got the check coordination results, more interactive, a lot of capabilities in here. And so it's modernized and it's ready to continue moving forward. So that's a big part of version 6. The 6.0 release had this this overhaul of the protection system. The use of Excel is all over the place in Synergi now. And if I go in here, I just run a load flow. And if we wanted to look at something like our balanced results here, we can click on this once and color the map. We could right click on this and show annotation. So we can put the maximum voltage on the map as annotation. So we've made the results easier to use, and but what you can also do is right click on this and do an open in Excel, and then a spreadsheet opens up, and all the results are sitting in here and in the spreadsheet that you can then use to do calculations, create your own charts, things like that. Charting, it's I used to have a boss who said we're not in the charting business, and he was exactly right. So we don't do a lot with interactive charting, but we do have you know, tools that like this voltage plot tool that sits here, and if you click on sections, it plots the voltage from the section you're on back to the source. You can look at loading and other things like that. But we've also done work on the on this chart view, and it's mainly around the need for doing interconnection studies. And you can pick something like biphase voltage and do a scatter chart of your whole system here. And there's ways that you can look at before and after. So you could look at a scatter chart and show the difference, how the voltages change when you do if you have a PV generator, those sorts of things. And if you have a point, you're wondering, well, this lateral or this area right down here, I'm getting fairly low voltage. Where is this? You can take one of these points on the chart, right click on it, and do a zoom to. And it'll take you to that line section in your model. So the charts are interactive. They don't look that great. That's why I made that comment about my boss, because we've never put a lot of effort into making these fancy. But if you want a fancy chart, you can load the data into Excel. Even from here, you can open in Excel. A lot of these windows have copies on them too. If you hit copy here, it puts this chart into the clipboard. I'm getting off in the details here. I'm going to swing back to the this DER ribbon again, and we have a screener on here. So if you have a customer and they want to connect generation to a section, then and they want to connect, let's say right here. You right click on this, you say set for analysis. You come up here to the screener application and you put in the size. So let's say they wanted to put in 5 megawatts there. That may be big for you guys are like dealing with rooftop probably, so maybe it would be more like 0.75. And so now we can come in and run this screener. And what this is going to do is, this is a very small impact, but these are all different screens that we have. And screens are just checks, validation that adding the generation is not going to create a problem. So we've got a series of checks, and this list is growing as clients tell us more checks that they want to add, and then we run through this. So our goal here is to give you an automatic screening tool that you can just run and get useful information for. There's lots of other applications up here we won't get into around DER, interconnection, that sort of thing. I think that's the documentation. We've got our user guide here has been overhauled since, that's not the right one. Yeah, the user guide is a book. Let me see here, the online help. Let me see what we get here. I may not have this set up on my computer. I don't, sorry. But I do have the technical reference, which is this. And this has also been redone in version 6. And we've consolidated a whole bunch of our technical material. And so it's a really easy to use interface here where you can look through different documents that we have. And we even get into things like calculations. And there's videos. There's a few videos in here. So this environment is, we built it because we had so many documents. And so now we can collect things and at least group them together as we continue to improve them. And down here in the seminar, we have things like, these are slides that we use for seminars and things like that. So a lot of material in the technical reference, and this is a milestone for version 6 to be able to consolidate this stuff and have a platform that we could use to move our technical material forward. And the online help is great as well. And I apologize, I don't have it installed here, but it's much easier to use, and it's been consolidated, and so it's greatly improved as well. All right. Well, do you all have questions on what I ran through?
¿Quieres, Carlos, preguntar si dentro de la parte técnica están los estándares que se utilizan para
Esa es una de las preguntas que yo tenía.
bueno, no sé.
Sí. Larry, one question about the types of analysis like low flow, short circuit, and any others. Do you have some standards to comply? For example, ANSI or I don't know,
Yet,
EEC, EIC.
yeah,
What standards do you comply with this this analysis? For example, short circuit analysis or fault analysis and so on.
Are you asking about the IEC standards for fault analysis?
Yes, for example, in the documentation, where can we find that reference to the standards that Synergi comply? This is
Well, the sorry, I was putting let me put some source impedance on here. So our if I go back here, the rundown of how we use sorry. So if we go in here under this document and under fault protection, fault analysis principles, this goes through, exactly how we do our fault calculations, and these will be consistent with the IEEE standards, and that is that's going to be the what's the number on this thing? 242, IEEE standard 242, the buff book. So I don't know that we have anything that we've say, well, this is a standard and we are compliant with it, because I'm not sure who would make that judgment, but all of our calculations are here, and I'm sure that they are consistent with the IEEE standards. Any textbook, the IEEE buff book, the brown book, any of those, we're doing those right on the money, and they've been checked and rechecked. Now the IEC standard, that's different, and that is something that we continue to work on. And sorry, my mic was away here. With the IEC challenge is that they are generally holistic, or not holistic, heuristic. That is that they're kind of made for, in my opinion, they're kind of made for engineers using their engineering judgment and charts, and so there's all these ways to kind of tweak the model, and multipliers to put on here, and under certain situations you're going to multiply this and divide that. And so there's I'm sure you all know the IEC standard. There's just this tremendous list of all this stuff, and it's an art. So our challenge is, okay, how do we take that artistic thing and make it actual settings in Synergi? And so it's not easy to do, and we're going to do it right. And so we have another utility in Europe who wants the IEC standards in there, and I believe that their other software say they do IEC, but really they just do IEEE. And and I shouldn't say just IEEE. They do IEEE like we do, and for the most part, IEC and IEEE are very, very similar. It's just these multipliers that are put on after the fact with IEC that is a challenge. So anyway, we do not do IEC right now, but we are working on it. Arc flash, do you all do arc flash studies? Because we do have the 2018 guidelines, IEEE guidelines for arc flash, and the 2012. We have supported the 2012, but the new guidelines are in there, and they're completely different. By the way, if you do arc flash, the 2018 guidelines are completely different from the 2012.
Laurie, is there a place in the documentation where they can find this standard, this IEEE or ISO or ANSI or whatever, that they can find in the documentation, just to show the regulator, because they are very concerned about the when the regulator asks what are the standards you are following up to, or you are with what kind of standards you are doing your calculations. They want to demonstrate that they are following, it doesn't matter if it is an ANSI, ICE, or other, just to show that they are following some kind of standard. Is there any place in the documentation where you can find this?
I think for the fault, if we don't mention the IEEE in there, the 242, we certainly could. But for the load flow, I don't know what standards there really are. There are, there's well-known approaches like kirsting. A lot of people talk about kirsting from New Mexico State. Our approach is very, very similar to his, but it's the standard is difficult. For arc flash, that's very simple, and you can see here that we have it mentioned, the 2018 guidelines, but looking at something like coordination, I don't think there is a standard. It's a difficult question. I'm trying to think of what we could do to help you, because your regulators are asking you to, they say, demonstrate that your analysis procedures are legitimate, I guess is what they're asking, right? And so you want to say they are legitimate, and here are the references to show that our analysis is consistent with these standards. And
no, it's okay.
Okay. Yeah. I'll keep thinking about it. I'm not sure. There are some IEEE test circuits out there, but they're very simplistic in my opinion. And we could put one together and show that our numbers match some other numbers, but we do a lot more modeling than there's a lot more complexity in distribution than those simple models. So it's but I don't know. I'll keep thinking about it. I'm not sure how to help you all. I mean, we do have a lot of technical documents, and so let me ponder it, and we'll see what we can do to help.
Pues,
Yeah.
sí, está muy bien. Quizás nos ayudaría mucho si más tarde, con algún comunicado, algún correo, nos pudiera aclarar, por ejemplo, el caso de cortocircuito, ¿no? ¿Qué método se utiliza? porque sí es importante para nosotros reportarlo a SENACE y a la CENER y a la CRE, porque este dato se publica, o sea, este dato es público y no tenemos ahorita certeza en la referencia que se utiliza, ¿no? Por eso la pregunta. Sí, sí, nos apoya Salvador ahí con la traducción.
Okay, they are saying that, for example, in the short circuit analysis, they are obligated by the regulator to publish that methodology or that calculation. So they need to publish in a public web portal, and they need to have a reference showing the method or how do they calculate that. So for them, it's important to have some kind of references. Talking about the short circuit, okay? But there are others.
Okay. So, I mean, we could put together a summary of what we do. If that's what you're wanting to publish, what we do, or do you want to have a list of other references?
What do you mean when you say other references?
Well, so the would it be adequate for us to, I mean, for CFE to publish that our fault calculations follow IEEE standard 399? Is that, and then somebody would go and look at that? I'm not sure, or do you want a summary document like if I go back to this to here, would you want a document like this that you would post that shows how, because if you want to know how we do a phase to ground minimum fault, well, here's the equation, here's the sequence domain circuit.
Carlos, pregunta si esto que estás viendo en la pantalla, eso es a lo que te refieres sobre cómo hacer los cálculos, o en realidad quisieras una referencia diciendo las instituciones que pudieran ser referenciadas, o te refieres al método de cálculo que nosotros estamos usando.
Pues sí, vaya, el método, pues hay métodos, son académicos muchos, pero en realidad hay criterios que se aplican en el cálculo que difieren de un lado a otro y son aceptados pues en términos generales públicamente, ¿no? Entonces si nos dicen, no, pues cumple con el estándar IEC tal cosa, bien. Cumple con el IEEE tal cosa, para nosotros está bien. Entonces nada más, no sé, Carlos, si por ahí nos quisieras ahondar algo para aclararles a ellos qué es lo que necesitan. Bueno,
sí, sí, sí. I think that the problem here is that in general terms is that we are in our standards, CFE, we are based on IEC standards. So in my understanding is that to see if the standards in the software like Synergi, there's some difference between the IEEE standards and the IEC standards. In that case, how we can show to the regulator that there is a compliance between the above the standards. So there is, I think that if you, Larry, help us to conciliate those differences, that would be great. I understand.
Okay, that makes sense. Yeah, that makes sense. So, we need to accelerate that effort and get the IEC get it integrated in here, or at least identify. I mean, our first step, I think, would be to just identify the differences in a document, and then that would be something you could show your regulators that here are the differences. And then our next step would be to add the capabilities for IEC into Synergi. Okay.
Larry, just two quick questions. If there's have been some improvement in the software in this version about the reliability indicators such as KID, KFE, etc. For in order to us to perform that kind of studies in the software. And the other question is a similar capabilities of the software for energy quality, and what we can do about that.
Okay. Yes. So for reliability, we have we haven't done work in the last probably 6 months, but we have done work. Let me get all your feeders here. And for reliability, I'm just take a look at this. We need to have customer counts. Yeah, good. We have customer counts. So there's 6 customers on this section. And then we also need to have yeah, so there's no exposure zones on here. And so this piece right here, the exposure zone, is the approach that utilities take, that we have in Synergi, is that all of the outage events get recorded in a database. So it'd be your outage management system, or whatever it might be. All those events are put into a database. Synergi will then go into that data and calculate how often an event occurs and what the causes are. And so the usual approach is to go into the model like this, and we've got a fuse right here. It'll take all of these sections and group those as one zone, and then it'll take all the events that occurred on any of these sections, add them all together, and calculate failure rates and so on. And that is over on the Forge ribbon under outage events here. And there's a little wizard that you go through to import the events, calculate the exposure zones and the failure rates and all that. And when it finishes in the warehouse, you will end up with exposure zones down here. Now it looks like you've got some. Yeah, so these are general. Just looking at these a little bit. So it looks like somebody was kind of experimenting around with these. What we should see are zones like this, where you've got your categories and then subcategories. So for this Forest Hills subdivision, I could go in and see that squirrels, I have failure rates for squirrels. And so these numbers are all calculated from those outage events and put in here. Now, if you don't have any of that, what we have added in version 6 is this stuff over here. And you can come in here and say, okay, for any section, I'm going to use this zone. So it's going to be for the entire model. But you could also come in and say, well, any section that is overhead, let's say, I'm going to use this. So that's any section that's overhead. We'll try this and see how it works here. And then this other one, I'm going to do this with anything that is underground. And then you could also do it by conductor type, construction, and stuff like that. And so this is a much more a broad, much less granular approach, but it should give us some numbers here. So let's see if we run reliability, what we get here. So with those, then we've got SAFE, MAFE numbers, SADI values, and then we have the CFE or the CFE and KD. These are the impact ones, and then we have the semis. These are due to customers who have multiple events. And then, so these are the interrupts, and then the durations for customers that continue to have events. So it runs quickly. And we also have charts in here. So we can see, trees are causing half of the events that affect safety. And so we've got a breakdown of what the root causes are. And then, just like all applications, you can go to the results tab and look under reliability and color the map by like CFE, for example, and see where you have higher CFE values. So the red sections are going to be higher. So I've got, these customers out here are about 4 times as many interruptions as these customers down here, for example. So the reliability runs, hopefully it runs very well. It has a wealth of data, gets down into very, very granular results, but you have to have some way to provide the outage information. So if you want to run the outage event tool, you have to have all of your events dumped out of your outage management system. Or you can go through, and an engineer can just use their know-how and their wisdom to do what I did, and that is to just put in some numbers and use these tools on the right over here to just assign those numbers to sections based on overhead or underground or the conductor type, things like that. But either way, the analysis should give you lots of results. On the power quality side, we have with power quality, we have the flicker that when I ran the intermittency analysis, the time series analysis, and we saw the voltages spiking a lot. You could see that flicker on the charts now, and it's not going to be in 6.4 the next update, but we are working on the PST, the short-term and the long-term flicker values, which is a kind of a sliding filter that would give you numbers that you could look at this customer and say their flicker is okay or it's not okay. But you can certainly simulate the flicker. Now on the harmonic side, that's an analysis that's easy to run. You just have to go in and right-click on a section, say set for analysis, and let me grab this one here. It's a little more interesting, I think, because of the capacitor. Set for analysis, and then we want to run the harmonic frequency scan. And this is going to show you where your resonance values are. So for that section that I picked, it looks like, maybe the 3rd, which is very low, isn't it? And that's so that may be concerning. Then we have a harmonic load flow. But for the harmonic load flow to work, you have to have a source. You have to have a large customer. And with that large customer, you have to set up here's a pulse width modulator. So you've got to put this harmonic profile in, assign it to a large customer, and then when you run the harmonic load flow, you'll start to see the effects of that. So you got some large customers down here, but the loads are small, I imagine. So you'd pick a harmonic profile, run a harmonic load flow. Yeah, it's having trouble. Usually it runs really fast here, but it's so So as far as power quality goes, I mean, we've got the reliability and the harmonic analysis, and we also have on the switching, on the capacity tab, a lot of the contingency analysis and those sorts of applications, and then of course protection stuff.
I suppose we can model the PV. I mean, if there's a big concentration of some domestic or industrial customers that in one area that use a lot of PV generation, and then model that generation and to integrate it in the network. I suppose you can do that with that too.
Yes, that's right. And you can, oh, so there was the harmonic data in here, THD, and then there was a, yeah, usually they have more charts in here. Should have seen some waveforms to see what's going on with that. Yes, if you have a cluster of customers with PV, then you could set up those. I think the best way is if you have a list of customers with PV, to put them in a spreadsheet and then import them with the data lake. And the spreadsheets are very easy to set up. You just list the customers and the size of unit and so on, and then you can import them. If you you can also, on your meters, you can have targets for generation, and when you run load allocation, it will also allocate PV generation. And then another tool that's that you can use is on the DER ribbon here, this thing called gens and loads. And let me just grab one feeder here for this. If I wanted to put a bunch of rooftop on this model, then I could come into gens and loads, and maybe we've got 250 kW among all these customers on this, and then give it a type here, and then when I run gens and loads, it runs it, and then these little things are solar. These are all rooftop solar. So now I've got the solar on this model, and I can run load flow. And sorry, let me pick a 8 o'clock at night. Not going to have a lot of generation. I'll go for 12 o'clock for noon here. So now when I run a load flow, then we've got PV generation here. So I've got 230 kW of generation. So with the gens and loads, you can put a bunch on your model, and then when you're finished, and if you were to save this model, these do not get saved. And then when you're finished, you go back into gens and loads, and you just say to clear it, and it takes it all back off. So it's just a way to kind of try things out, say, well, what if I had a bunch of rooftop? There's other approaches, but all right.
I have a few questions about Data Lake works with other tools, database tools to import data different from spreadsheets, for example, database.
Yes, so you can import data, and it depends a lot on what the data is, but the Forge tool, you can use Forge to bring in data, and not just for model building. So if you had PV data, for example, you could write scripts with Model Forge to do that import. But with the data lake, here, if you look under the schema, these are all the ones that we have in place now, and it's a little bit cryptic, but if like for generator values here, the DER 101, these are all, if you're using a database, these would be the field names. If you're using a spreadsheet, these would be the column names. And then you put the data in here. spot loads, distributed loads, so on, protect the devices, and we're happy to add more in. Many of these are coming from coming from clients who have asked us to put in data schemas for the data lake. If I'll bring up the spreadsheet here that I was using earlier. And I've got accumulated a lot of data in here, but this is the sheet that has the demand data in it with timestamps. But I've also got, here's a DER 102. These are generators. These are residential rooftop generators assigned to distribution transformers and so on. We've got loads. So it's very easy to see in a spreadsheet, but we use the same schema on a database. And so if you wanted to load from the data lake from a database, you just go in here, run the data lake, and then you say, I want to use a database. And then you'll have to pick the database off this list. But if you have a set of data that you want to bring into Synergi and we don't have the schema in data lake now, then let us know and we'll put it in. And then we could send out an update for you. Okay, what were the other questions that you had?
Okay, so for a few questions about power quality analysis, it reports the impact of harmonics on losses.
No, I don't believe so.
Okay.
Yeah.
For the hosting capacity analysis, do you include some reports or some information that will help us to determine mitigations for the impact of penetration of solar power plants?
Yes. Yeah. The hosting capacity report will show you what the bottlenecks are, and if I'll go back in here, run this real quick. It runs fast. And so when we look at this, we can see the yeah, this is an odd circuit here, but yeah, so most of these are at my maximum, but here I've got this section here, I'm down at 8 megawatts, and here's the limitation. So I can see I'm hitting a maximum. The 5 categories that I had mentioned here, the overall limit is in this column, and then the loading limit, this is the thermal limit, and I don't know why we don't have the buy right here, because we should have the buy. Let me take that's weird. Sorry, let me just take a screenshot of that. So on the maximum voltage, we can see the section that is causing that limit, delta voltage, reverse flow. That's not going to be and then max voltage, or I'm sorry, minimum voltage limit. So the culprits are listed here, and so you can go out and zoom to those. And so I know I've got a high voltage problem here. I can use the other tools in Synergi to try to fix that. So we do not have a tool that suggests mitigation, but we are looking at mitigation analysis with respect to other sorts like planning application. So we do not have it, and it's not going to be in the 6.4 update, but we are looking to start on some sort of an expert system that if we do see a high voltage problem, for example, if that situation meets a bunch of criteria, then we're just going to assume we can mitigate it, for example. But you could imagine that's going to be you know, a lot to try to figure out for an application like that, but we are going to tackle it. So there is a lot of information on the hosting capacity, and then you can color too if on the results here for incremental hosting, we were looking at maximum generation, but we can also see what's the maximum generation if we're limited by voltage. And so now everything is red because it's at my 10 megawatt overall maximum, but I can see a few sections here that aren't red. So that one right there, you know, so I've got some sections in here that have high voltage. High voltage is inhibiting them getting their full hosting capacity value, and so on. Here's delta volts. Yeah.
There are some considerations about the forecasting of generation, the increasing photovoltaic generation into the system. It could be done some analysis to evaluate the impact of the growing of generation, this kind of generation.
Yeah, and that's a good one. Today we do not have that, but we do have a forecasting application in here. And the forecasting application, you put in the base year and the future year, and you put in information that describes how loads are going to grow in the system. And you kind of pick and choose the information that you want to provide. It's usually in the form of a curve, a 10-year curve of growth. So you set that up in here. And then you can run forecasting. So I forecast my model. And now with my model forecast, I can go into the multi-year analysis. So I can run my load flow over the next 10 years. And so when I do that, here's my demand growing. And so this is really great stuff. I mean, I'm just looking at one feeder here. It's so so we have the forecasting. What forecasting does not have today is the generation piece. So that's we've got to do some work on that, on this forecasting here, to let you put in information about how generation is going to be growing in the future years.
Okay.
Yeah.
A question about Google Maps. Have some rights to use of Google Maps or for publication the results into that platform?
I don't know. That's a good question. I've heard from one of our folks that there might be some sort of licensing. I don't know. What we do is we write out a file that is a format that Google Earth uses, and then we send that to Google Earth, and then it just shows that data. Now on the geographic view, you can also use Google, and that's so licensing wise for publishing, I don't know, I think is the answer. You'd probably have to look into that to see if CFE, and you know, just imagine any sort of data. So you know, you set up the question as, you know, can CFE put data in Google Maps and publish it? Is that something we can do? Then if the answer is yes, then you should be able to use Synergi to do that. But if the answer is no, then that just means in general, CFE or any utility can't do that. I think for the desktop, you know, what I did is perfectly legitimate. You know, I'm I'm not publishing anything. I'm just using Google Earth. It seems like a lot of our clients who do publish to the web use ArcMap, the Esri web maps, or some sort of a GIS mapping system that's made for online.
Okay.
Yeah.
Do you have time or some time to speak about the software?
Yes. Yeah, we should schedule, and we can have regular meetings if you all would like. And what I meet with a lot of utilities once a month, and we just have a meeting time on the calendar. And if you all are busy, we can cancel, or if sometimes I'm traveling, we have to cancel. And if you would like to go, we could do every 2 weeks for a while. If you want to meet more frequently, I want to respect your time. Solver, I can certainly talk about it, but it would be helpful to have more, to have exactly what you're trying to do with Solver. If we need to talk about the code and the routines and such. I should point out too that I don't believe version 5 supported Python, but version 6 you can I should be able to, I can edit this thing, and so here's Python codes you can write to do things with, and so it's using Solver, but you can write your stuff in Python, and that's very convenient. And yeah, I'd be happy to do that. Maybe on our next meeting, or if we wanted to have a separate meeting on Solver, and if you kind of let me know ahead of time what it is you want to talk about, we might have other folks who could probably be better to talk to you about it.
Okay, thank you.
Una pregunta más de Centro Sur.
Adelante, Wilfred.
¿El Data Lake permite importar la totalidad de un circuito?
That's like is here is asking you if the data lake can import the all our circuits. I suppose in a region. I don't know.
Import the what? I'm sorry. It was.
Import a circuit, a whole network.
Oh, no, it. So the data lake is just there for supplemental data. So categories of data that you might want to bring in, like you can kind of see on this list here, generators, loads, profiles, things like that. But if you want to bring in a whole circuit, middle link would probably be, it depends who's doing it. So if this is for CFE in general, then I very much recommend Model Forge, because I remember all the SQL and how your models are, the data for your models is set up. And so Model Forge, as that worked, it kind of made us start to think about Model Forge. We went about that same time, maybe a year later, we went to another utility and developed a model build for them. And then we realized, we should just be talking straight to the database. And so we built Model Forge, but you all kind of inspired us to do that. So your models should really be ideal for Model Forge. But if you have folks who are just needing to get models built, then middle link on the support ribbon under schemas, middle link here is a text file format where you put in model data for sections So if you have section data, you put in a record that has the nodes. There's load information and so on. So this looks like a lot, but it's just a lot of details. You just really need to put in the data that you're concerned about. So you would need nodes. So you would need a list of 101 records that have all your node IDs and coordinates. Then you need sections. So you'd have a bunch of 201 records. And then you need feeders, which are 301s. And that's it. So with that in a middling file, you're able to load a model, and then you can start thinking about what other details you need to add. And it's completely up to you all. But MiddleLink is very flexible. You know, it's wide open. You can see all the data and everything. So that's a good approach. Okay.
Thanks.
Yeah, sure.
How is your time, Larry?
Yeah. It might be good if I guess are we going to work with Salvador to come up with a regular meeting time? Is that
okay?
And,
yes, I know that there is a lot of anxiety of knowing all the features, all the possibilities that we can do in this amazing tool. But guys, I would like to take the willingness of Larry of having recurrent meetings, maybe bi-weekly. So I think that by now it has been a very productive meeting, just to give you an overview what are the difference between version 5, version 6, what is the potential, and we can continue with Larry talking about this potential features or functionality and, on this tool. If you accept, we can set up this meeting maybe bi-weekly. This is not the formal training course and nothing similar, but just to give you a clear idea of what you bought and what is the potential of this tool. So there is a lot of stuff yet to show. There are solver modules that you bought that we can review with Larry. But let's keep it clear, simple, and do it in pieces with an agenda and in a bi-weekly basis. So if you agree, we can finish this meeting for now, and let's set it up, that meeting, if you agree. Okay, I know that there are some other points missing in our meeting. So there are, we have to continue with the meeting without Larry, but for now I would like to show appreciation to Larry for this interesting presentation, and to Kyle Williams for being here. Thank you very much, and yes, to continue exploring the potential of this tool. So thank you, everyone. Let me get an agreement with Larry about when could be the next one, and then I will let you know next date for having the other session. Okay. So thank you, Larry.
yeah.
And that is that's all for now.
Okay. Well, thank you very much too. And yeah, we'll schedule the next one. And then if your group there, if you just come up with a topic, I think we can get into specifics. If you want to dive into something, then we'll go through that, and I'll show you how to use it, answer questions, and take your feedback for improvements, and that'll be great. So thank you all for your time today too.
Yeah, thank you, Larry, and thank you all.
Larry, just last questions about we would like to have your agreement to download or have the video of this talk and distribute it to our group of engineers in CFE.
Okay. Yes. Yep. I will. Should have been recording, so I'll grab that and then we'll get it to you all. Yep.
Okay. Thank you very much.
Okay. Yeah. Well, thank you. Okay.
The last time.
Okay, Larry. Many
Okay.
thanks. Okay. No. Okay, that's all.
Okay. Great. Okay. Thanks. We'll talk to you later. Bye-bye.
Bye-bye.
Pues,